Okay, let's see. Right, let's see what's going on here. Right. How do I find the live here? Okay. Yeah, okay, live. Hi guys, I'm just setting up the live at the moment so that I can see the comment and that sort of stuff okay. Right, and then I need to see the comment. Right, hello. Okay. And then how's my YouTube? How do I see the YouTube live comment? Oops, what happened? Right, okay, live. So I need to set up my YouTube account as well, because quite a few my actual student at school can't access TikTok, so I just check that. Yeah. Right. Okay. Let's see. Right. So right. Right. Just so why this is so dark? Learn more. Right. Is it dark? Why this YouTube is really dark? Anyway. All right. Thank you for coming. Hi, Krish. Is that Krish which I haven't passed the level 1 math exam. Okay. Is it Krish from yeah, I don't know. I know quite a few Krish, but from Max or Elvis. Are you Elvis? All right. Hello. Oh yeah. Yeah. Hello. I just going to start talking about doing the lesson for level 2, NCEA level 2. I guess what I finally passed. Molly Woolly. Okay. NCEA level 2 algebra today. We are focusing on NCEA level 2 algebra. And then are you starting or finishing? I'm starting. I'm trying to set up the YouTube and that sort of stuff. Yeah. Right. Okay. So I'm starting. How many of you guys are online? Okay. They 7 students are on. I believe this one is on YouTube, right? And then 23. Okay. So quite a few students are online, so I can start working on that lesson today. I want my lesson structure is gonna be the not basic. I can't really say basic for level 2 anymore. So the lesson teaching, so for warming up, I'm going to talk about the achieved level first, and then after that, I'm going to talk about merit and excellence. And for warming up, I'm 2023. So the question that I'm using as the past exam, which is 2024 and 2023. Okay. Then I will give you extra questions if you want me to provide. Okay. So right. Okay. Would this be posted on YouTube? Yes. I'm doing the YouTube channel as well, so that if you prefer watching on YouTube, you can go on my YouTube channel, which is if you go to my profile on TikTok, and then you can find YouTube. Okay, and then after that, because of the connection issue, I will use YouTube for Q&A. So that before I start doing the lesson, I just want to explain what's going to happen today. Okay, first I'm going to, is there any paper that I can use? Yep. So opening as a warming up. So I'm talking about this kind of stuff first. Then the second one is I'm going to talk about factorizing and then simplifying. So for example, this kind of question. Okay. And then after that, I'm talking about exponential equation, which is, for example, this kind of equation stuff, exponential equation. And then after that, I'm talking about the lesson is going to be about logarithm, which is this one, nay. Okay, this one. Okay. So this is a step. So the first 30 minutes is going to be a solid algebra. And then the second one is exponential equation. And then the third one is a logarithm. Okay. And then after that, I'm doing the, I will give you the Q&A so that you can ask me a question. But you're welcome to ask me a question during the lesson. But if I can't catch it, sorry about that. Okay. Right. So first, for more like, this is more like for me to warm up. As a live streaming is, I need to warm up first so that I can get used to it. So for this one, let's do this kind of question. Okay. So I just want to see, can you see both of the channel? Yeah. Right. So before I start talking about this one, I just want to make sure you guys understand the exponential law. So for this one. So you need to understand square root, or this one is a fifth root. Okay, and then this is a to the power of 3, and then to the power of 8. These kind of stuff. I just want to go over here. For example, 2 to the power of 3. My phone is not doing well. Can you see? Is it too blurry, or should it be fine now? Right. So that I will talk about that. 2 to the power of 3 means 2 times by 2 times by 2, isn't it? Which is 8. Okay. Then 2 to the power of 4 is double it. So 2 to the power 2 times 2 times 2 times 2, which is 16. All right. And then 2 to the power of 2 is 2 times by 2, which is 4, isn't it? Right? How much is 2 to the power of 1? Can you give me an answer? Yeah, 2. That's correct. Yes, that's it. 2. 2. So this one is 2, isn't it? And how about 2 to the power of 0? How much is that? Good. 1, 0, Right. So that 2 to the power of 0 is 1. Because if you see this one as a power number and the index number dropped 1, that means becomes half, isn't it? Drop 1, this is half, and another half, right? So if you drop from 1 to 0, another half, which is 2 divided by 2 is 1, which means if you see 3 to the power of 2 is 9, 3 to the power of 1 is 3, 3 to the power of 0 is also 1. So the first row is any number to the power of 0 is always 1, okay? Which is 100 to the power of 0 is 1, and 0.1 to the power of 0 is also 1, okay? So, yeah, which means, how about 2 to the power of negative 1? How much is that? Yeah, NCEA level 1, yeah. Yes, that's it. So x2, so if it's going down, divided by 2, isn't it? You can say 0.5, but I prefer stating half. Because if you do 2 to the power of negative 2, you can do 2 to the power of 1 over 4, which is, you can say 1 over 2 to the power of 2. Like that, okay? So that a half is a great answer. Yeah, reciprocal. Yes, that's it. So if you see negative in the as a index number, it's gonna be reciprocal. Okay, reciprocal number, for example, is half of the reciprocal number, as if you times reciprocal number of half here, it's gonna be 1. What's the number? 1 over 2. No, 2 over 1, isn't it? Okay. So, which means if you do to the power of negative 1, it becomes reciprocal number. So, for example, a to the power of negative n means 1 over a to the power of n. Or, for example, a to the power a over b to the power of negative n means b to the power of, b over a to the power of n. And then if you if you get little bracket, you can also write like this as well. Okay, so far so good. Right, so the next step is gonna be the reason why I make the space here, as I just wanted to ask you, how much is 2 to the power of half here? Tan-san, yeah, level 3 integration, I can do that, but good, square root 2, yeah, good. Today I'm focusing on level 2, okay guys, that's the main, yeah, all right. Is that okay? So this one is square root 2. Then I just want to tell you this is a basic rule here. Yeah, how is it? The square root 2. Yeah, I will talk about it. Right. So if you're doing 2 to the power of 3 times 2 to the power of 2 as 2 to the power of 5, isn't it? Because 2 times by itself, 3 times here, and then 2 times by itself, 2 times here. Oops. So if you times them together, that means 2 times by itself, 5 times, isn't it? Right? In this case, if the base number is the same, and if you multiply those two numbers, what happened to this number to here? Adding, isn't it? Right? Which means if the base number is the same and then multiplying, you add the powers to get this number. Okay? So for example, a to the power of 5 times a to the power of 3 is a to the power of 8. Okay? If you think following this structure, a to the power of half times by a to the power of half must be a to the power of 1, isn't it? Oh, sorry, I wanted to use 2. 2 to the power of half times by 2 to the power of half is 2 to the power of 1, which is 2, isn't it? Then times by itself twice to get 2 is square root 2, isn't it? Square root 2 times square root 2 is 2. I'm pretty sure it is a level 2. Yeah, this is a level 2. Yeah. I have a question. What level is this? Yeah, this lesson is level 2. This is a warming up, so this knowledge is halfway between level 2 and level 1. Right, so this one is, what did I want to say, as this one. So this is why this is square root 2. So if you see 2 to the power of 1 over 3, this means this is cube root of 2. So if you times by itself 3 times, you get 2. Because you add the index number, isn't it? Together, all right? So if I use a number, for example, 8 to the power of 1/3, this one is cube root 8. Then you can write like this, cube root 2 to the power of 3 here. 2 times 2 times 2 is 8, isn't it? So you can cancel this 3 and this 3, and then you get 2. Okay? I can rewrite like this. 2 to the power of 3 to the power of 1/3. Okay? Then I will come back here. But before I start talking about this one, I just want to use this space to talk about this one. Right. A to the power of 2 to the power of 3. If you want to calculate this one, this means a to the power of 2 times by itself 3 times, isn't it? So a to the power of 2 times a to the power of 2 times a to the power of 2, which is a to the power of 6, isn't it? A times a times a times a times a times a. Then I just want to see the relationship between those two numbers and this number. Yeah, then this one's 2 times 3 gives you 6, isn't it? So if there is a number here and then bracket and then another index number here, you do times to undo the bracket here, okay? Which is, if you look at this one, do you remember this one? Cube root, wasn't it? Cube root means a to the power of 1/3, which is, if I write this one in index form, not square root or cube root form, index form, you can times these two, right? And then you get 2 to the power of 1 here. Okay, so this is a basic exponential law, We are using this one a lot today. Okay, right. Okay, just peel this one off so that I can show you anytime. Right. So let's talk about the actual NCEA level 2 question. Okay. Okay, you're right. Okay. That's helping me. Good, 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 good. Good. Yeah, all right. So if you look at this one, this is a fifth root, isn't it? Okay, fifth root means I can, so was square root as, for example, square root a means a to the power of half. Cube root a was a to the power of 1/3. So this one's fifth root. So this one we can rewrite like this. 1/5. And then I copy this one down. But before I start copy this one down, I just want to calculate here. 4 bracket 2n to the power of 3 means 4 times 2 times 2 times 2, which is 8. And then n times n times n, which is n to the power of 3. So numerator, it's going to be 4 times by 8, 32, and then n to the power of 3. Then over n to the power of 8, isn't it? Okay. Then I just want to ask you, this one, if you see the same letter on top and bottom, what can you do? What would you do? Can we find Walker's book detailed solution anywhere? Detailed solution. Walker's math is if you want to talk about the Walker math book, I don't know. I don't want to bleach the copyright, so I'm not doing it. But anyway, 1.4. 1.4. As I'm going to do 1.4 session the other day. Okay. Yeah. Good. Right. So I will focus on this one. So a to the power of 3. For example, a to the power of 3 means a times a times a. And a times a to the power of 2 means a times a. So if you do a to the power of 2, if you see, for example, 2, 3, a 3. If you see this kind of fraction, this means 2 times by a times by a over 3 times by a times a times 8. Because this one is multiplied together, you can cancel one each, wasn't it? Okay. So this one is 2 over 3a. So let's see, look at this one. So that means 3 of n can cancel here, right? Which means 32 over n to the power of 5 to the power of 1/5. Does it make sense? Yeah, or cancel. That's it. Yeah, subtract or cancel. That's good, 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 good. Yeah, yeah, good. Then this one is 32. I just want you to sort of remember these number 2, 4, 8, 16, 32, 64, 128, probably up to here. For level 2, that should be fine. This one is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. This one is a 2 to the power of 5. Okay, so I can rewrite 32 for 2 to the power of 5, and then numerator, denominator is n to the power of 5. And then, as I said before, if index number inside, there is an index number inside of the bracket and outside of the bracket, you can times, isn't it? Okay. For this one, you can rewrite like this, isn't it? 2 over n times by itself 5 times, then times by itself 1/5. So you can cancel this one and this one. So the answer is going to be 2 over n. This is how we do it. This is a sort of warming up and then covering the basic skills that you can deal with the next step, logarithm and the exponential. This is quite complicated, but if you can understand this one, that's really good. Okay, next. This one is n to the power of 3 over 16 n to the power of 6 bracket negative 0.5. This one is, yeah, thank you. Oh, good. Why did we put the 2 bracket against? Yeah, doesn't matter. Yeah, I just wanted to explain 2 brackets here so that I can simple. My main worry for this question is some of the students make mistake just canceling this one and this one, and that's a big mistake because this one affect on this one as well. That's why I just rewrite this one into 2 to the power of n to the power of 5 as this one, then to the power of 1/5, and then you can cancel this one, isn't it? But it's totally fine if you can skip this process, okay? I just wanted to make sure why I can cancel this one at top and bottom at the same time. Yeah, okay. Right, okay. Cool. So the next question is this one. This one was, do you remember this one, square root? But what we want to do here is, this one was the same. Before we start dealing with the outside bracket here like that, this one as well, you're trying to simplify inside of the bracket first, okay? Ignore this one first, okay? Ignore means you just copy this one down here. Okay, then let's think about it. As I mentioned before, if you see the same thing multiplied on top and bottom, you can cancel, wasn't it? Okay, n times n times n over 16 n times n times n times n times n times n times 1, 2, 3, 4, 5, 6, like this. And then if you cancel one each, nothing left behind. In this case, what shall we do this one? In the denominator. No, I mean numerator. What would you do? Is there any answer here? Keep on doing math. You are very talented. Okay. Yeah, that's it. 1. Because this one came from basically n divided by n, isn't it? If you cancel it, this is 1. Like 2 over 6. If you divide by 2 here, 2 here, it's going to be 1/3, isn't it? Okay? Like 1. So the numerator is going to be 1, and the denominator is going to be 16 to the power of negative, n to the power of 3. Then, what shall we do for this one? Right. Let's think of the coefficient and variable separately. That's probably better. And then I just rewrite this one. I just want to use half. Okay, so 1 over 16 times by, as I mentioned before, a to the power of n as 1 over an. a to the n, which means if you see 1 over a to the power of n, means a to the power of negative n. I use this notation, so which means n to the power of minus 3 to the power of negative half. Agree? Good. Yeah, reciprocal. Yeah, cool. It's a Sean. I just finished my year 11, the last lesson for my year 11. Yeah. Anyway. Yeah, okay. This one, so 1 over 16 is, yeah. What is the question? To simplify each, leaving your answer with a positive index. So we can't really use negative index here, right? So let's see. This one, 1 over 16 is 16 is 4 to the power of 2, isn't it? So 1 over 4 to the power of 2 is this part, okay? And then times by negative half. Then, is that complicated? Is it this way? Is this way complicated by any chance? And you times this one and this one together, which is 3 over 2. Is it too complicated? Yeah, should I? Oh yeah, Sean, yeah. Oh, good to see. Anyway, yeah, we never learned to separate them. Okay, so yeah, we probably better not to take this way, eh? Right, so this one, okay, so yeah, if you 16 to the power of negative 3 to the power of negative half, shall we take the reciprocal of this one? Yeah, let's do that. Sorry. In my way, this is a sort of easier, but from here to here, sorry, mate. I just canceled this from here. Sorry. I just jumped from here to here. Oh, my mistake. Sorry, if I check the comment and then do the lessons a bit by them, I'm sorry, I don't get it. Right, okay. So this one is, if you take reciprocal, which means we're gonna be to the power of half, isn't it? Okay, if you cancel negative here, which means you need to change this one into reciprocal of this one, which is 16 to the power of n to the power of 3. Okay, then this one, 16 is 4 to the power of 2, and then n to the power of 3 to the power of half. In this case, you have to times half individually here. Okay, so half times 2 is 4, and then 3 times half is n to the power of 3 over 2, like that. This is the correct answer. Yeah, or you can also write like this as well. Square root 16 n to the power of 3, which means 4 to the power 4n to the power of n, but both should be correct. Anyway, yep. Okay, so that next, right? My planning. Where's my planning paper? Where's my planning paper? This one. Right. So next, what we are doing. Here. Okay. Exponential. First warm up is done, and then simplifying. Okay, so that next one is it -3 bra? Then he swaps them. Yeah, yeah, -3, isn't it? -3. Yeah. Anyway, simplifying 2024 question 2 B. Yep. Okay. Question 2B. Well, question 2023, 2024, 2023, question 2, question 3A. Right. So NCEA loves simplifying fraction. For example, this one or this kind of simplifying. So that I will talk about the simplifying fraction first, and then start talking about yeah. Sorry. What I yeah then is it not -3? Then he swap. But can you do the first one? Okay, simplifying fraction needs help. Okay, yeah. So simplifying fraction here, as this one, as you probably have seen this kind of stuff in level 1, but when we are doing the level 1, the expression was much simpler. For example, let me say, let's say x squared minus 9 and x plus 5x plus 6. If you want to simplify this one, you are factorizing on both sides, isn't it? Okay. Then do you remember how to factorize numerator and denominator? I always say bracket x here, bracket x here. Okay. So it's quadratic, both numerator, denominator. Yeah, good. So if you times together, you get 6. Adding together, you get 5. What two number can you think of? If you add them together, 5 times them together, 6. Yes, 2 and 3. Okay, 2 and 3. And then this one is this factorization is the most important factorization. You are using this skill over and over for level 3. So I really want you to understand this one. X squared minus 9 is, if you factorize that, this one is x squared minus 3 to the power of 2. I always say a squared minus b squared type factorization. This one is a plus b, a minus b. If you expand, a times a is a squared, a times negative b is ab, negative ab, b times a is ab, and then b times negative b is negative b squared, isn't it? So the middle term is cancelled out. So if you expand this one, you get a squared, take away b squared, which means if you see a squared, left side squared, take away the right side squared, you can always factorize in this way. Okay, so if you want to understand visually, this one means plus, minus, like that. Okay, which is this one is x to the power of 2, take away 3, which is 3 to the power of 2. So if you factorize this one, what do I write? X, and then what number do I write here? You didn't understand. Sorry. Yeah, 3 and negative 3, that's correct. So positive 3 and negative 3. So if you factorize this one, positive 3 and negative 3. Then if you find the same thing on top and bottom, you can cancel. Then answer as x minus 3 over x plus 2. This is a basic stuff. So basically what you are doing is this one, but the factorizing is a little bit more complicated. So before I start talking about this one, I just want to talk about this factorization more, because I'm sure one of the question you will see this kind of this type of factorization, because this is the most important factorization for calculus level 3, which means you need to master before you go to level 3. Okay, so if you follow this structure, can you, all right, let's say 25a to the power of 2 minus 9 to the power of b to the power of 2, 9b to the power of 2. Can you factorize this one? Zoe, you don't have to put a bracket for the answer, or more like if it's not wrong, but it looks nicer without bracket, because yeah. Right, so this one is, you can, if you follow this structure, this is 5a to the power of 2, isn't it? Right? And then this one is negative 3b to the power of 2, isn't it? Then you can say this is a squared, this is b squared, right? So if you are factorizing that, this one is going to be 5a plus 3b, 5a minus 3b. Does it make sense? Is that okay? Right, so if you can understand this one, and then another stuff I need to tell you as a diamond method or any kind of factorization, any style is all right, but for me, diamond method is easier to teach, so I usually use diamond method. I just need some question from my TikTok previous right, diamond method. Right, okay, so I just want to show you which one is it, diamond method. Okay. Okay, so for example, this one, I just give you the simplest factorization using diamond method, but can you factorize this one? This one is easy. You can do guess and check as well. But what I'm teaching to my year 11 kids is like this. You are crossing line here and then put line like this, okay? And then our goal is bracket and then bracket. And then you can't use ordinary factorization because we've got 3 here, okay? So we need to figure out how to factorize this one, but using diamond method, okay? If you, then we are filling the number here, 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 okay? First number is this number. You are copy this part here without to the power of 2, okay? So 3x and 3x. Then which number which fits here is this times by this, okay? This number times by this one, which is -6, isn't it? And then number which fits in the bottom is now the coefficient of x, which is -1, okay? If you add them together, and then now you do, if you add them together, you get -1 times them together, -6. What two number can you think of? Yeah, this is a level 2 algebra, but this is sort of revising. Hang off it. No, thank you. Yeah. This one is revising level 1 at the moment. Right. So this one, can you? Yeah. Yes, that's it. So if you put -3 and 2, if you add them together, you get -1. Times them together, you get -6, isn't it? Okay. Then this one, this bar is for fraction. Okay. Then if you can't simplify here the number, simplify the number here, you leave this one on the left side of the bracket and right side of the bracket, and this one is positive, so you put positive here. Okay. Then if you can simplify this one, you have to simplify here before you fit this one in the bracket. So if you do this one, it is x in -1, isn't it? Okay. This is factorized using diamond method, okay? If you expand this one, you get this one. Okay. Good. So I will use these two methods, the diamond method and this one, a squared plus b, take away b squared type. Yeah, to solve this question. Okay. All right, just move this one a little bit. Yeah, oops. Okay. Can you see properly? Yes. Yes, okay. Yep. Right. So for this one, you are looking at the denominator and numerator individually, okay? Right. Shall we start from, the denominator? 9x squared take away 16. Can you 9x squared take away 16? Can you factorize this one? Good. No problem, Zoe. Yeah. Yeah. Right. So this one is a squared take away b squared type, which is a plus b, a minus b. Okay. So this one, 9x to the power of 2 take away 16. This one is 3 to the power of 2 take away 4 to the power of 2, isn't it? So if you are factorizing this one, 3x plus 4 and 3x minus 4. This is a denominator, okay? So far so good? Okay, right. Next, so that shall we do numerator here, okay? Right, 3x to the power of 2 minus 10x plus 8. So I use diamond method. Okay. 3x squared. So I write 3x here. Then 3 times by 8. 24, and then negative 10 here. Okay? If you add them together, you get negative 10 times them together, 24. What two number can you think of? Times them together, and 24, adding together, negative 10. Yes, negative 6 and negative 4. That's correct. Negative 6, negative 4. And then if you see the fraction which you can simplify, you simplify this one, and this one is 2, right? So numerator is gonna be x minus 2 bracket 3x minus 4. Okay, so this is a numerator, this is a denominator. So you write numerator as x minus 2, 3x minus 4, and then denominator is gonna be 3x plus 4, 3x minus 4. Can you see the same thing on top and bottom? Yes, you can cancel this one. So the answer is x minus 2 over 3x plus 4. Okay. Good, good. Why is it 3x minus 4 in second bracket? This one. This one is for this one, you copy this and this one down left and right. Okay, and then this one is x is here, negative 2 is here. Is that okay? Why did I learn this bracket in high school? Anyway, yeah, this is a problem. I don't know about the grade, which grade, but this level is in New Zealand. We are teaching for this standard for year 12, which is 15, 16 years old, 16, 17 years old, like that. But this one has achieved questions. So it's the lowest level question. Anyway, right. So simplify another question. 2023. Question 2b. No, 2020. Simplifying 2023. Question 3. 2024, question 2b. Right, this one. Right. Okay, like your method is great. Very easy to understand. Yeah, this is quite easy, isn't it? This method. Yeah. All right, this one, we are simplifying this one. Right, this one is not super straightforward, but when you see the simplifying and then top and bottom one, this one is sort of easier looking than numerator, isn't it? Okay, let's start from denominator. 5x plus 3x to the power of 2. Can you factorize this one? Don't go bracket xx. You are looking at the common factor, which is x, isn't it? So if you put x in front of the bracket, this is a factorized form, isn't it? Okay. I just put 3x in front because we usually put x in front and then constant in the number in the back, isn't it? Okay. So denominator is going to be this one. The numerator is a problem A. But if you look at 9x squared and 25, can you think of anything? this one is 3x to the power of 2, isn't it? And this one is 5 to the power of 2, isn't it? Okay. Then the key is there's a square root here. If square root, we can't get rid of square root, you can't solve this question, isn't it? And then do you think NCEA will give you the question which you can't simplify here? No. Which means this somehow you can factorize this one in this way, so that you can get rid of square root and the square at the same time. And if you look at this one, 3x and 5, did you see this one somewhere? Here, isn't it? Okay. In this case, in the future, you are canceling this one and denominator this one. In this case, can you guess or can you expand this one? Yes, square root, yeah. This one is 3x plus 5. 3x plus 5, isn't it? Timesing it itself twice. 3 times 3 is 9, 9x squared. 3 times 5 is 15x. 5 times 3x is 15x. 5 times 5 is 25. So 9x squared plus 30x plus 25. If you expand this one, you get this one, which is this one. Which means if you factorize this one, you get this one. 3x plus 5. Then you can cancel this half and square root. So denominator, numerator is going to be this one. And the denominator is going to be like this. And then same thing, cancelled. 1 over x is the answer. Is it perfect square on top? Yes. That's a perfect square. So in the end, I will talk about the perfect square form only if someone asks me. Yeah. Yeah, I lost you there. Okay. Okay. Right. This one, yeah. Perfect square form. I will talk about perfect square form in a Q&A probably later. Right, so this is simplify a and the number question 3. Question 3. 1B. Question 1B. 1B. Simplifying question 1B, question 3AI. Question 3AI. No, I think this one questions 3A. Sorry, I got lost. Which question do I have to do? Oh, this one, yeah. Yeah. This question. Right. So this one is a little bit complicated. Oh, this one, 1, 2, 3, 4, and right. This one is not simplifying, so that I will come back this one later. This one is not something I wanted to talk about. So let's do quadratic equation thingy. Looks like they love quadratic equation, which is question 3. Okay. To this one. Questions. Right. Q1. Q1B, Q1, Q3A. Q3, question 3A. Yeah, this one. Right, shall we solve this one? So 5 to the power 5x to the power of 2 plus 13x minus 6. Solve following equation. Do you know you will get, I believe you know that you will have the resource sheet, and then there will be the information about the quadratic equation. So if quadratic equation is ax squared plus bx plus c equals 0, the solution is always minus b plus minus square root b squared minus 4ac over 2. Okay? So whenever you get stuck, you can use this one to solve this equation. Okay? So this is sort of, yeah, you can use calculator to figure out answer. But you got to be careful. This is plus and this is minus, so that you need to do individually. Right. So there is, right. So if you move, so you need to have the equation in this form. Okay. So 5x to the power of 2 plus 13x minus 6 equals 0. Okay. Yeah. This one you can actually, but anyway. So let's use quadratic equation formula. This is A, this is B, this is C. Negative 6 is C. So x as numerator as 5 times 2, which is 10. Denominator as first one is a negative 13, and then plus minus square root. 13 square as 169. You can use calculator for it. And then negative 4 times by 5 times negative 6. So 2 negative turns into positive. 4 times 5 is 20. 20 times by 6 is 120, isn't it? Okay. So negative 13 plus minus square root 289 over 10. Okay, am I correct? Yeah. I just check the answer just in case I don't want to make silly mistake here. So 2023. Question 3.1. Looks like I made a mistake somewhere. 189. Yeah, 289. Square root 289. Oh, 17. All right. Okay. I didn't make mistakes. This one is 17. So, which is negative 13 plus minus 17 over 10. Then I just wanted to talk about plus and minus. The paper, blank paper here. No, this one's. So this plus minus showing the two different number. So for example, 1 plus minus 2, this means 1 plus 2, which is 3, and 1 take away 2, which is negative 1. There are two numbers, okay? If you see plus minus, which means this one is negative 13 plus 17 over 10, which is 4 over 10. And the negative 13 take away 17 over 10, which is negative 30 over 10, right? So if you simplify it, 2 over 5 and negative 3. This is the answer for this one. Okay, so this is how you use quadratic formula. Okay, I just wanted to show you because I want to talk about discriminant soon. Okay, right. Okay, good. Right, and then which question am I going to? Right, and this one, simple and quadratic formula, question 2a. Yep, I did a question 3. Oh, I did question. Is this in 2023? Question 3a1. And then next questions 2024, question 2a. Right, we're gonna do 2024, question 2a. Right, this question. Okay, let's do this question. So it doesn't look like quadratic equation for this one, but what is the difference between the ordinary equation and this equation? This equation is a little bit looks hard because x is in the denominator, isn't it? Okay. In this case, you're always trying to think of trying to get rid of something which makes you hard to solve. Okay. So what I want to say is to get rid of to the power 5 over x to the power of x on the denominator, what can you do? Right, you can times x on both sides. So if you times x here, you can cancel x here, isn't it? Okay. But whatever you do one side, you always have to do the same thing on the other side. You times both of them by x. Okay. So that means 3x times by x is 3x to the power of 2. 14 times by x is negative 14x. And equal 5. And then if you move 5 to the other side, 3x squared minus 14x minus 5 equals 0, isn't it? Okay, then you are using quadratic formula. So x equal to a minus b squared plus minus square root b squared minus 4ac. So x is denominator is 3 times 2, which is 6. Numerator is negative 14 times by negative b, negative, so 14 plus minus square root. All right, b squared, 14 squared is 196. You use calculator, okay? And then 3 times 5 times negative 4. Negative turns into positive. And then 4 times 5 is 20 times, so 60. Okay, so 14 plus minus square root, 256 over 6. 256 as a, you can do 256. This is a familiar number, 16 to the power of 2. So that 14 plus minus 16 over 6. And then you can add 14 plus 16 as 30. So 30 over 6, and 14 take away 16 is negative 2. So negative 2 over 6. So 5 and negative 1/3. Okay. It is not wrong. If we just factor, yeah, you can factorize that too. You can factorize that you can factorize this one, and for example, my way as well. Then you can do factorize as well. But what the main point, what I want to talk about this one is I want to talk about discriminant after this, which is 23 discriminant as question 2024, question 2C. Not 2C, not 2C. Question 3. Who is it? Wow. Time flies. What is it? Equation. Find the range of a graph. Doesn't have cross. Okay. No. Sorry, it takes long. Ooh. Where is the discriminant one? Yeah, this one. I wanted to talk about discriminant. That's why do you NCEA students did us find this hard? I don't know. A high school teacher gets paid in New Zealand. How much? Can we move on the logarithm? Yeah, after the discriminant. Yes, I can. IB legend and in the chat, I fear. Yeah, IB is cool as well. Yeah, I think discriminant. I can teach IB as well, but yeah, today as NCEA, and then for IB student, this one I hope you can do this one easily, because IB is obviously we do this kind of stuff as well, but discriminant is important as well. The quadratic equation, find the discriminant of the quadratic equation, this one, okay? What you are doing is 3x2 minus 5x plus 2 equals 0. And the discriminant means, all right, 2a minus b plus minus square root b squared minus 4ac. We call b squared minus 4ac as a discriminant. And the discriminant is really important because when discriminant is 0, there is only one solution. And if discriminant is negative, there is no solution. And the discriminant is positive, there are two solutions because there is some value here and then we use plus minus. Okay, so b squared is a negative 5 times negative 5 is 25. And then minus 4 times by 3 times by 2, which is 24. No, it's 25 take away 24, which is 1. So discriminant is 1. Quite easy, isn't it? And if you've got a formula sheet, you don't even need to remember this one. So there is like this super easy achieved question. So that if you are not confident in merit question here like that, you better work on the achieved question as well, so that you can collect credit properly. Right. Okay. So shall we do? Yeah. What's the time? It's quite long. Okay. Logarithm. Shall we do logarithm? Yep. So log is this one. Okay. So this one is log means log A, B, C. If you say this one, log means this. You only need to remember this one, and then otherwise you can basically do it easily. A, B, C means this one is A to the power of C is B. Okay, you always remember this one. Okay, A to the power of C as B. Okay. Then if you look at this one, all right, it's the same. 5 to the power of x is 625. 5 to the power of x is 625. In this case, 5 times by itself, how many times gives you 25? So all you have to do is you hit 5 times 5 as 25 times by 5, 125 times by 5, 625, which is 5 to the power 4, isn't it? Right? So that means 5 to the power of x equal 5 to the power of 4. So x equal 4. Okay? Good. Is that okay? Which book is it? This one is an NCEA past exam. Okay? Right. Yeah. Let's do. So this one, this concept and this concept is basically the same. So if you're dealing with the log and exponential is basically the two sides of one coin. Okay, so if you can understand this one, you can understand this one. Right. So for this one, if you're doing an exponential equation, all right, I just move this one there. Right. So you want, if as long as you have the same base on left and right like this, you can solve it. And if you look at this one, 9 and 27, this is both 3 to the power of something, isn't it? Okay. 9 is 3 to the power of 2. Then to the power of 2x plus 3. Okay, this is the left side, and the right side is 1 over 27 is 1 over 3 to the power of 3, isn't it? Which means 3 to the power of negative 3. Okay, so the main point is we want to have the same base number here. Okay, then to the power of x. Then if you look at this, you are timesing, isn't it? So 3 to the power of 2 bracket 2x plus 3 is 3 to the power of negative 3 to the power of x, so it's a negative 3x. So base number is the same. So all you have to do is you connect this one and this one. These two must be exactly the same value. Otherwise, it's not going to work, isn't it? This equation is not going to work. So 2 bracket 2x plus 3 is negative 3x. That's how you do it, okay? Then you unbracket here, 4x plus 6 equal negative 3x, okay? Then you move this one, yeah. So I want to have x on left, so plus 3x, minus 6, minus 6. Then this one canceled, so that 7x equal negative 3, divided by 7, so that x equal negative 6 over 7. This is the answer, okay? Right. Okay. Yes. Yes, this is 6, 7, isn't it? Yeah. Okay. Right. Okay. This one. Right. This one is something you have to. If you see that. Okay. I will show you the formula sheet. Where is that formula sheet? This one. Yep. I hope that my camera will show you properly. Right. This, if you see the. Right. Okay. Right. And oops. Yeah. Oh yeah. Right. If you see the formula sheet here. Okay. Orientation and all right. Okay. Can you see this one? Okay. All right. This one if you are timesing the x and y, you can convert into plus. If you are dividing, you can convert into minus. This is really important. And then if you do x to the power of x, you can put x in front, or you can also say the same thing from here to here. If you times by n times by log something, you can put n as a index number. Okay, this one as a basic rule, which is you will see this one in resource sheet for NCEA. Sorry, right, oops, yeah, and rotate, yeah, okay, sorry, this, yeah. So if you have that formula sheet with you, you can find this one. It's not that hard. But anyway, this one is actually, I didn't need to show that one. All you have to know is this one, wasn't it? Okay, so logarithm as a log a b to the equals c means a to the power of c equal b. Okay, for this one is the same. B to the power of 2 is x, so x is b to the power of 2. Okay, then this one is 3b to the power of 2 is y, so that y equal 3b to the power of 2. So you got to be careful. 3b to the power of 2 means 3b to the power of 2. Okay, then this means 9b to the power of 2, isn't it? Okay, then if you look back here, write y in terms of x. Okay, so this means you need to write y equals something x. Then if you look at this one, b squared means x, wasn't it? So you can plug x instead of b squared, which is 9x. Y equal 9x is the answer. Okay. Right. Okay. So okay. Can you try one with different base later? Yeah. Okay. Yeah. I can do that different base as well. Yeah. Right. Okay. Next, next logarithm as log 2024, we did C. 2023 question 2. 2023 question 2. Yep. Okay. Yep. Right. So this is basically the same. Find m when if the log log 2 bracket 3 blah, blah, blah. Okay, so this is the same. Log ABC means a to the power of c is b. Okay, this to the power of this is this, which means 2 to the power of 4. 2 to the power of 4 is 3m plus 1. Okay, and so if you take 1 away from both sides and flip left and right, 3m is 2 to the power of 4 take away 1. Is that okay? Which means, okay, 3m is 2 times 2 times 2 times 2, which is 4 times 4, which is 16. 16 take away 1. 3m is 15. So m is 5. Okay? Is that okay? Why is it paper so much harder than 2024 algebra? Oh, I wonder, eh? Yeah. But I used to write exam in Japan as well. But if you write an exam and then if society criticize it as too hard. And the next year we tend to write a little bit easier one. So that's why probably. Anyway, so this one, what approach do I take? The same. You can put 3 to the power of something here, but it's gonna be too big. So this means 3 times by log x64 equals 6, isn't it? Right? So in this case, 3 times log equals 6. So you can divide it by 3 on both sides, which is log x64 is 2. Okay? Then, as I mentioned just before, a to the power of c is b. So that means x to the power of 2 is 64. Right? So that x is 8, isn't it? In this case, you can put plus minus as well. You can have negative number in there. Right. Should it be? Okay, so that basically most of the level 2 log achieved level question, if you follow this one, you can solve it as an. Okay. Yeah, this one is a different base. So shall we do this one or shall we do this one? It's called a dash, but not sure. Okay. B please, C please. Okay. So all right, C. Okay. So I just right. There are lots of people say C. So I do C first and then B second, okay? Right. Yeah. So if you're adding, you tend to times. So if you look at the same base log, there is a rule that you can do. What's the paper? So log a x plus log a y as log a x times by y. Okay, then I just give you another example, another rule. Log a as log a to the x over y. So if you are adding, it's gonna be timesing, and if you take away, it's a fraction. Okay. So this is really cool thing that you can convert from addition to multiplication, then subtraction to division. So that so I quite like this transformation. I believe it's cool. But anyway, right. So this one, the same base here, right? And then adding, isn't it? So we can times this one and this one together. Right. So let's say find the value of this one. So 6 plus log b to the power b, and then you can times this one and this one. And then I just change this one. Shall we change this one this way? And then plus log b to the power of half. Wait, just a moment. No, you don't need to time this one. We are using other rule. Sorry about that. This one is log a to the power b. And if you times by, for example, n here, this is exactly the same as log a to the power of n. B to the power of n, which means, for example, log a to the power of x5, this means exactly the same as 5 log ax. Okay, this conversion, and another conversion is this one, log 2 to the power, so for example, 2, 8. This one is log 2 to 3, which means 3 log 2, 2. Log 2, 2 means 2 to the power of something gives you 2, which is 1, isn't it? So this value must be 1. 1 times 3 is 3. So when you see the base number and that number the same, you can convert into 1. Okay? So I'm using this logic and this logic to solve this one. Okay? If you convert 1 over 3, 1 over b to the power of 3, this one, then half, isn't it? Then because this one has an index number, you can put this one in front here, this one in front here. 6 minus 3 log bb plus half log bb. See, the base and this number is the same. So this part must be 1, this part must be 1. Which means 6 take away 3 plus half. 6 take away 3 is 3 plus half. So the answer is gonna be 7 over 3, no, 7 over 2 or 3.5 or whichever you want. Is that okay? Did you pass level 2? Bro, if I'm not in kind of... Good. No worries. Right, okay, shall we do B? Okay. So B as a sign. So having the same base is really important, isn't it? This one is the same. Having the same base is a bit really important. Having the same base is super important. So if you look at 5, 25, and 125, you can sort of think, oh, this is 5 to the power of 1, 5 to the power of 2, and then 5 to the power of 3, isn't it? So that sense is really important. If you look at this one, all right, let's say this one, 5 to the power of 7x plus 6 as a denominator or numerator, and then denominator is 25 negative this one, isn't it? This means 5 to the power of 2 to the power of negative x, isn't it? Okay. Then, again, you can times this 2, isn't it? 5 to the power of negative 2x. Then this one is a denominator, right? Then there is a negative here, which means reciprocal. Which means, okay, 5 to the power of negative 2x. This means exactly the same as this. This comes here and then get rid of negative here. Is that okay? And then if you're timesing the same base number here, you add the index number together, wasn't it? So the left hand side is 5 to the power of 7x plus 2x is 9x plus 6. This is the left hand side, right? And then right hand side, what is the question? Find the expression for p in terms of x. So we need to write p equals something x, isn't it? Anyway, right hand side is 25. 125 is 5 to the power of 3. So if I put p here, right? And then if you see this one, you do times, isn't it? Okay. So the right hand side is gonna be 5 to the power of 3p. And then I will look left hand side and right hand side. 9x plus 6 equal 5, 3p. Then this one equal this one, isn't it? Because it's the base number is the same. So 3p equal 9x plus 6. And then you need to get rid of 3, isn't it? Because our goal is p equals something x plus something. So you do divide by 3 on both sides. Divided by 3, so 3x plus 2 is the answer. Done. Right, when you multiply something with the same base, you add power. Yeah, yes. Did I make mistake? Yeah. Yeah, negative 2. Yeah, that's it. Oh, yeah. Is that okay, Illy? I don't know. Oh, thanks, mate. Okay, good. I'm a little confused of changing the powers to log form. Changing the power to log form. Okay. So is that Archie? Yeah. How about this part? Do you find this is confusing? Oh no, that's fine. Okay. So this one. How about this one? Is that the confusing stuff? I got it now. Oh, okay, no worries. Right. I think it's a time. So I wonder. I was gonna do lots of stuff. Yeah. Anything all right? Shall we do? Yeah. I was gonna do Q&A or something like that. Hello. Yeah. But yeah, after 12 minutes, and then I will go on only the YouTube channel so that I can focus on the student who is on YouTube. Then I can answer the question and that sort of stuff. But yeah, that quite yeah. So if you are interested in joining my Q&A session on YouTube, and then this is a YouTube link on my on my TikTok profile, so that if you can join that, and then eventually I will grow. I try to grow the YouTube channel as well, so that you can follow there. That would be good too. How did you get so smart? Yeah, thank you. Yeah, I've been teaching math more than 25 years in two different countries. I used to be a teacher in Japan, math teacher in Japan, and I've been teaching math in New Zealand as well. So the teaching in two different countries helps me, yeah, a lot. I managed to understand the two perspective. Yeah. Right. Is there any? Shall I? How many minutes do I have? Yeah, 40 minutes. Sorry, I don't get it. This is a YouTube one, and then this is a. Right. Is there any? What school have you taught at? What school? And then can you please help me with calculus? I need help with kinematic. Okay. Yeah. Kinematic. I don't know the terms, master. I didn't teach level 2 calculus, but I can do the obviously do level 2 calculus as well, because one of my follower asked me. So yeah, yeah, kinematics. I got to have a look what it is. Yeah. Yeah, yeah. Kinematics. Yeah, okay. I just memorize kinematics. Is that the calculus? It's basically, yeah, physics. Oh, physics. I'm not too sure if it's a part of math. I used to be a good at physics, but I'm not too sure nowadays because I've only taught math and sometimes Japanese, but I usually teach only math because I love math. Yeah. Yeah. Right. I wonder if, yeah, how's that? It's math, but it's similar to physics. Oh, yeah. Okay. I will have a look. Sometimes in New Zealand we give the physics type of calculus question, isn't it? Yeah. Yeah. But yeah. Is there anyone who want me to explain this one or anything like that? And then I will to take me exam. What do you mean take me to take my exam? All right. Yeah. I can do question D. You can. So you can do. So no point for me to explain this one, now. Yeah. And then anyway, something. Yeah. If it's quite straightforward one as well. This one is. Can you see? Yeah. Sorry. Right. Okay. Sorry. For the is a person who are asking me to do this one on YouTube channel, so that I will start. Yeah. So that I'm doing I'm explaining this one to the followers on YouTube and TikTok, and it's sometimes really, yeah, hard to check on both sides. So eventually I'm going towards yeah, anyway. Yeah, right. So this one is 4 to the power of x take away 10 over 4 to the power of x equals 3. So if this one is, because this one is quite complicated, this is hard, isn't it? If this one is like this form, oh, my pen is not working properly. I just changed my pen. Right. So if this one is x minus 10 over x equals 3, like this. This one is easy, isn't it? You are timesing x on both sides, and x to the power of 2 minus 10 equals 3x. And then you move this one this way, x to the power of 2 minus 3x minus 10 equals 0. And then you do bracket x. If you times in 2, you get negative 10. Adding 2, you get negative 3. What two number can you think of? Yeah, this one is negative 5 and positive 2, right? Then in this case, this one, the answer is x equal 5 or x equal negative 2. But then now we look at this one. I used x here instead of 4 to the power of x. So I need to plug 4 to the power of x back in here instead of x. 4 to the power of x equal 5, or 4 to the power of x equal negative 2. Then we have to look at this one. Do you think this is possible? 4 to the power of something can't becomes negative number, isn't it? So this one is not correct answer. But how can you find x value here? This is level 2. Yeah. So this one, as you are using log, as I mentioned before, log a b equals c. This means a to the power of c equal b, isn't it? So this means 4 to the, so x is log 4 to the 5. 4 to the power of x is 5, isn't it? Okay, this one is good. This one is yeah, good answer. Yeah, log, yeah. And if you want to figure out the value exact that in decimal, you can do it, but this one is exact answer, so it should be fine. Yeah. Right, okay. And then this one. I found this one super easy. Can you see this one? Wow. So the level of sound is measured in a logarithmic log scale using the decibel, the formula of this one. And then D is a level, decibel level, and then P is the intensity of the sound, and then P0 is the weakest sound that human ear, sorry, not car, E-A-R, ear can hear. And then cooling the fan has this decibel of 38, and then a heat pump has a decibel level as 30. So the cooling fan sound intensity as more than 6 times of that heat pump sound intensity. So that if you understand the basic logarithm, you can actually, solve this one easily. So again, I just mentioned log a, b, c means a to the power of c is b, okay? Then we have to show that decibel 38 is 6 times, more than 6 times than decibel 30. What you do is basically when you are dealing with the NCEA, there's always formula here, right? You plug it in and then look from far, okay? What I mean is you plug this value here instead of D, right? So 38 equal 10 log 10 P over N, right? So let's say this one is cooling fan, so PC, okay? Then 30 equal 10 log 10. So this is a heat pump, so PH over P0. Okay. Then we are trying to figure out the cooling. So this one and this one, we compare this one and this one. And then we need to show more than 6 times of this one is this one. Right. So if I follow this structure, first I just divide by 10 on both sides. So right, this one is 38 over 10 equal 10 PC over P0. Okay? Which means 10 to the power of this one, isn't it? So PC P0 equal 10 to the power of 38 over 10. Then I just want to see this one as well. Right. So if you just follow the same structure, this one is going to be PH over P0 equal 10 to the power of 30 over 10, isn't it? Which is 3 here, right? And then all you have to do is compare this one and this one, isn't it? The same PC divided by P0 and then PH divided by P0. So if you compare this one, you can find the answer, okay? So it's easier for me to type the N if I use decimal here. So I just change this one decimal and this is integer, right? 10 to the power of 3.8, wasn't it? Yeah, 3.8 as right, okay. Is 6,309.57. Okay. Whereas 10 to the power of 3 is obviously 1,000, right? Okay. Which means you can say this is more than 6 times than this one, of more than 6 times of this one. Okay. Okay. All right. Okay. So that yeah, I get a point if I do more than 2 hours of live streaming, so that I've got 7 more minutes on. Is that 7 more? How many minutes do I have? I wonder how long I have been doing the live streaming. I've been doing on. Yeah, about 7 more minutes, and then I think I will close. But is there any questions? Or any is there any questions? Can you also take log of both sides? Yeah. I said hi. I don't understand. I don't understand how to create both of those equations. This one, both of this equation came from here. I just plugged because it says decimal as 8338 for the fan, so that I just put this one in here and then other one in here. Is that okay, Archie? Okay. Any question? How does it becomes PC and PH? Okay. So is that this one you're talking about, Archie? So the value of this one. So we are comparing this one and this one, isn't it? So yeah. So this one is this one, right? What does PH NPC stands for? Oh, yeah. So I just PC, PC as a cooling fan. I just put C from this C, and then PH for heat pump H. So there's not much, how to say, I don't really, you can use any letters for this one. P1 or P2 is totally fine as well. All right, okay, good. All right, good. Right. So what shall we do? So if I've got 5 more minutes, and then I can actually no, this is quadratic formula. Consider the equation 3x to the power of 2 minus 4kx plus k squared equals 0. Using the quadratic formula, find a simplified solution and quadratic. Yeah. Makes sense. Okay, I understand. What do good. Right. Is there anything basic? You're right. Okay. This I can do this one if you want to, or what shall we do? Or we can do this one as well. This one's, I think this one's an excellence question. Oh, but this one's not gonna be 5 minutes. Yeah. Can you answer? Yeah. Hi. Archie. Does it make sense? Can you answer? Shall I do this one or the other one? One before, please. Okay. One before. Right. Okay. This one is a really important skill, actually. So using quadratic formula, find the fully simplified solution to the quadratic equation in the terms of k. Right. So that, yeah. So that in terms of k, find the fully simplified solution quadratic. So that we just use quadratic formula. So x equal. So this formula is going to be given. Okay. And A is this one, and B is this one, and C is this one. So A is 3, B is negative 4k, and then C is k squared. And then all you have to do is you actually plug it in here. And then this one is given in the formula sheet. So there should be, yeah, hopefully you can find it easy. Yeah. All right. So that I just, my phone camera is not working properly. Right. Okay. So that, for TikTok, my phone battery is dying. So that if after this, I will talk about the excellence question there. So if you are you want to take the lesson after this, please come to my YouTube channel because my phone's battery is dying. So all right, anyway, so I will plug that one in. B minus B, so negative 4k, so the x equal as negative and negative cancelled, and then plus minus square root b squared. Negative 4k times negative 4k is 16k to the power of 2. Minus 4 times by 3 times by k to the power of 2, which is negative 4 times by 3 is negative 12. So negative 12 k to the power of 2. Reconnecting. To a, so that's 6. Okay, then you just basically adding together. 16 take away 4k2 over 6, which is 4k plus minus 2 to this part as 2k to the power of 2 square root, isn't it? This one. Okay, so this one and square root cancelled, so 2k over 6. So this one is the two values, isn't it? 4k plus 2k 6k to the over 6, which is k. This is a first one, or 4k minus 2k over 6, which is 2k over 6, which is k over 3. So these two, k and k over 3 is the answer. Okay, so that if you go to my profile and then there's a YouTube links there, I think I can't really, my other phone battery is about to die, so I just close the live for TikTok now. But thank you for coming, and then I will upload some other NCEA exam stuff, level 3, level 1, and level 2 quite often from now. So if you can follow on my TikTok, that would be great. And if you can follow on my YouTube, that would be super. Right. Thank you for coming. And then no, don't go. Yeah, right. You're a legend. If you can come to my YouTube channel, I will do the excellence question. But I can't really hold on longer because its battery is dying. So but thank you for coming. And then see you next time. Okay. Cheers. Right. Okay. So that right becomes 2k squared. Okay. How did it becomes 2k squared? Okay. I will do it. Just a moment. I just close this one. Yeah. Okay. So this one for this. How did it when you simplified how? Okay. Right. So this one is, if you see square root here, which means you need to square root, for example, let's see, 16. This means you need to make squared here, so you can cancel square root and square at the same time. So you need to change the form inside of the square root into something to the power of 2, which means 4 to the power of 2 gives you 16, isn't it? Then you can get rid of 2 and square root at the same time. You get 4 like that. For here, I wanted to use the same logic. So for example, x to the power of 2, you can get rid of this one and this one at the same time. So x, isn't it? So if I say 16x to the power of 2 square root, this one is 4 to the power of 2 and x to the power of 2, which means 4x to the power of 2 square root, right? So you can cancel 4x. So this one is the same. 4k to the power of 2 means 2k to the power of 2, isn't it? That's why you can cancel this one and this one. Is that okay, Archie? Good. Right. Yeah. Right. Okay. So shall I talk about this one's a complicated one, and then that's about it for today. Is that okay? Makes sense? Yeah. Right. That's good. That's good. Right. Okay. So this one is an excellence question. Let's do this one. So if you simplify, you get this one. So this one is a sort of easy excellence question because if you expand, and then trying to figure out something, then you manage to change this form into this one, and then you're correct. Right. So in this case, what you have to do is you are expanding, but as I mentioned before, for example, n to the power of a times n to the power of b as n to the power of a plus b. Okay, we are using this one a lot here. Okay, so that if you times, so let's expand top and bottom here. Okay, top is rewrite this one here. X3 2 plus half. Oh no, annoying. X to the power of 3 over 2 plus x to the power of half bracket x to the power of half minus x to the power of negative half. This is a numerator. So if you expand this one, this times this, because base number is the same, and then we are timesing these two together, that means you add the index number together, isn't it? Okay, which means this times this as this plus this, so which means x to the power of 3 half plus 1 half. Why my camera is not working properly here? Anyway, this one plus this one is 2, isn't it? Okay, and the next, this times this is a take away, and then 3 to the power of 3 over 2 plus take away half, so x to the power of 2 over 2, which is 1, isn't it? Okay, and then so we did this times this times this. So next, this times this as x to the power of half times x to the power of half. Base number the same, so you add them together. Half plus half is 1. Okay, and then this times this, take away half, so x to the power of 0. Okay, were you guys here when I was talking about the index numbers? So this one is cancelled. So any number to the power of 0 is always 1. So the numerator is x squared minus 1. Right, let's see denominator. Denominator is x to the power of 3 over 2 minus x to the power of half, then to the power of 2, so I just rewrite this one again, x to the power of 3 over 2 minus x to the power of half. Then this times this, again, x to the power of 3 half plus 3 half, 6 over 2, which is 3. This times by this as by negative x to the power of 2. This times this, negative x to the power of 2. This times this as positive x. Right, so that means x to the power of 3 minus 2x to the power of 2 plus x. Then I just factorize this one because I want to. So it's x bracket x squared minus 2x plus 1. Can you factorize this one? You can. X bracket x plus 1 to the power of 2. Minus 1 to the power of 2. Like that. Okay. Then this is a denominator, number on the bottom. This is a numerator, number on the top. But x to the power of 2 take away 1 means x to the power of 2 take away 1 to the power of 2. If you are factorizing this one, a squared take away b squared type, which is a plus b bracket a minus b. So if you are following this structure, this one is x plus 1, x minus 1, isn't it? So this one is a numerator, this one is a denominator. So I put them together, x plus 1 bracket x minus 1 over x plus 1, x bracket x plus 1. Let's say this is, oh yeah, not plus, minus 1, x minus 1. It's a times repeat itself twice, so I just rewrite again here, right? So that I can cancel one of those here. Okay? Then answer is this one, which is same as this one. Okay. Okay, so this one is quite a long time I did, but yeah, that's probably is there any questions in the end? I think I've done enough. Wow, yeah. Thank you. Yeah, this one's cool, eh? Math is cool. Yeah. Yeah, that's yeah. Is there anything you want to ask me? Yeah, okay. This one. Keep on doing math I used to do. I think my student didn't show up on YouTube in the end. Right, okay, so that, oh yeah, that was great engagement, Archie. Thank you for coming. And then I will probably go now. Okay. Right, that's probably it for today. And then yeah, see you another time. Right, cheers. Bye. Thank you. Yep. Cheers. How do I? No, I don't know how to stop. No. How to stop the video here. Good. Okay.